Far left, you did 100 times 6 plus?
Plus 75 times 15. And then over 100 plus 75.
What'd you get?
I got 9.86 meters.
All right. Anybody disagree? Nice. See? Much easier when we just do it the simple format. Yes?
And would it not be negative 15? Oh, wait, never mind.
So here's the deal. And again, the negative sign's kind of weird. If you do exactly what Noble just did, you start here, you don't have to worry about negatives at all.
Yeah.
Nothing's to my left. I'm just going right. And then your life's just better, honestly.
Okay.
I mean, it works no matter where you pick, but why make your life more interesting than it has to be? By the way, why do we use the word light, Miss Noble, for describe the beam?
Wait, say that again?
Why do you use the word light to describe the beam?
Maybe to show that it doesn't weigh a lot.
It doesn't weigh a lot, so therefore I have to worry about what it's doing to my center of mass, right? If the beam was not light, I'd have to deal with another force in the center somewhere, right? This would be the beam's weight.
Okay.
Is that okay?
Yeah.
And it's a little early for that, but I want to point that out. All right, but try example number 3. Since I was really close on example number 2, my guess is example number 3 is where I'm wrong. Do the things have to be attached to each other to have a center of mass, Miss Welko?
Can you repeat that?
Do the things have to be attached to each other to have a center of mass?
No, I don't think so.
I think a lot of people would think, well, but I'm talking about where do I put my finger, right? If I put my finger someplace, they got to be attached to somehow so I can touch. Turns out you really don't need that. The center of mass refers to the center of all the little objects you're talking about, right? And it could be things that are not touching each other.
Right.
And in which case we use the phrase system, the center of mass of the system. Okay? So for example, the classic example is if you have a star here, and you have another star here, these are called binary stars. And they're attracted to each other because they got gravity. With me so far, Ms. Welko?
Yeah.
Now, they go in circles. How do the circles go? Let's try it like this. What's interesting about these circles, they go around the same central point. What is that central point?
The center of gravity.
Center of gravity or the center of mass for the two? How come? Well, because if there's not an outside force, you can't get pushed, right?
Right.
Motion and stay motionless acted upon by an outside force. There's no outside force between these two stars. They're just hanging out together. Their center of mass can't move. And so the only way they can form an orbit is around this central spot, which cannot move until something comes along and pushes one of the two stars from the outside. Does that make sense?
Yeah. That makes sense.
And so things can have centers of mass even if they're not touching each other. For example, try problem number 1 on 418. Who wants 2B? Nobody wants 2B? All right, we'll give it to Mr. Kerrigan. Mr. Kerrigan there? Hello there. You got 2B, man. Let me know when you're ready.
Yeah.
And then we've got 2 masses on the end. This weirdo put a 20 on one side and a 35 on the other. And there's an 8-kilogram bar in between. Agreed?
Yes.
Okay, where are you going to start?
You were gonna start.
What point are you going to pick? Far left, far left.
Yeah, let's go with the far left.
All right, let's not go negative numbers right now. Okay, so then I'm going to go, well, I know how to do the first one. It's 20 times 0. I'm going to do that one over there, right? 35 times 1.7 away. How many do the bar?
You do the bar. I don't know.
You do the bar by simply saying, look, it is got a center mass somewhere along this length. If it's a uniform bar, it's going to be halfway point, right?
Yeah.
And that halfway point is 0.85 meters from one of the ends, right?
Yes.
And so I act like all of its mass is concentrated there. So I would get plus, finish me up. What's the mass of the bar?
Mass of the bar. Sorry, I have to go back to the worksheet.
Okay.
It is 8.
8. And the length we just said was 0.85. And now I'm going to divide by the total masses, which now I've got to add the 8 to the bottom.
5. Got it.
And I get 1.05-ish. That doesn't change much. All right, now let's see if we get it ready for crazy new physics thoughts. Let's try number 3. Everybody needs to try number 3. All right, what do you got?
Like to set up the problem, I went 2.5 is equal to 2m.
Whoa, the center mass of the car, isn't that before people get in? Empty car.
Oh,
They're asking you where the center mass is. Although you asked an interesting question, that'd be a good one. All right. So how am I going to deal with this? I've got people in the car, right?
yeah.
So I've got a 70 times 2.8, right? Plus another 70 times 2.8. You okay with that?
Yeah.
Plus I got another 70 times 3.9. And then another 70 times 3.9, and another 70 times 3.9. But obviously the people in the car aren't going to be the majority of the center of mass. What am I going to do about the car? Where does its mass act like it is?
2.5.
At 2.5 at its center of mass. So 1,050 at 2.5, all divided by 1,050 times 70, or plus 70, plus 70, plus 70, plus, I just write 350, but my bad. 1, 2, 3, 4, 5, love it. Who's got the answer? No one's got the answer? Oh.
2.74 meters.
2.74, that sounds right. I was going to guess it's about 2.75 meters, so I'm going to go with that. Should be just a little to the left of the 2.8ers. Questiones? So the only thing different about this is when you see we have a center mass of some object, you may just throw it in our equation just like just if it was a point mass and all of it was concentrated in one spot. Doesn't matter how big it is, it acts like it's going through the center of mass. Is that okay, Mr. Sussman?
Yeah, but so you just like multiply the center of mass and like the top equation, like combine it.
Well, you just it just becomes its mass times its distance from the center, right? That we picked. The spot we picked.
Oh, that makes sense now.
That's all we're doing. We're just pretending like it's like another passenger in the car. You know, it's completely surrounding them, it's bigger than them, and all that stuff's true. It acts like the center mass is where it acts like it is. You know something interesting? If a human being has a center of mass somewhere, usually in their chest area, does that make sense? Check this out. When do you fall down when you lean? Mr. Sussman, when do you fall down when you lean?
Probably on the right one.
Well, yes, but what's the point at which when you bend too far forward, suddenly you can't hold yourself up and you're going to fall down?
Oh, when your center of mass is.
Yeah, when your center of mass is no longer over your legs, just a little bit farther out. Why? Because your weight acts like it's there and it falls down.
Okay.
When the weight's sitting here, it's trying to get through your legs. It can't make it. But when you lean out, I got nothing below me, I'm falling down. It's why we primarily build walls straight up and down, because we want the center of mass of the wall, wherever it is, to be above the wall itself. When you build a wall this way, things get really tricky. Something else got to hold that sucker up. All right, Miss Winter, you get the next to the last challenging problem on number 4. Let me know when you're ready.
Alright, so the first thing, so you gotta set your equation up, so
You got to know where you're starting. Tell me where you're starting.
I will do the x. So I did like one equation for x and one equation for the y direction.
Absolutely should. Good job. That's the first starting point that's confusing. All right, what do you got for x?
I did 0 for the length for the first, or the radius of the first,
So m times 0 plus
plus I did 10 centimeters.
m times 0.1, right?
Yeah.
And what about this guy up here?
Well, we don't, does that one matter right now? Or do you
It does. It matters. What's its distance in the x direction?
0.
0. So it's an m plus 0 times 0 as well. Is that what you meant by does it matter?
I mean, I guess I didn't realize you would have put that one in at all, but I guess it won't change anything.
Right, because you picked this spot. Now, if you pick this spot, you'd have to have both of those on there, wouldn't you?
Right. Yeah.
All right. Because again, this thing, if you put your finger dead center, ignoring this thing, right, like it doesn't exist, this thing's going to rotate to the left, isn't it?
Yeah.
Because it's got more mass over there. But we're going to measure it from that position, so I don't have to worry about that at all. Okay, what's my total mass?
N plus M plus N.
M plus M plus M. Let's do a little mathage. I get 0.1 M over M3M.
Yes, 0.03.
033-ish, isn't it? Or 0.3? 0.33. Meters. And if you use centimeters, you get 3.3 centimeters, right?
Yeah.
Nothing wrong with that?
And then in the y direction, you do